All right, I wanted to do sort of a stream of consciousness review of some of the material, most of the material we've kind of covered so far this semester. I think there are certainly many of you who have a good picture of what's going on, and some of you who understand some of the parts, but I think sometimes taking another look at this and maybe seeing the big picture context of it all might help make the pieces fit together. So I'm just going to haven't really planned it out too carefully, but we'll see what comes out of this. So here we have a Java file, and when you start running the program, it starts in this main method, and I'm going to get rid of that line. So what are programs made up of? Well, for the most part, they are made up of statements, and statements do things. So if I run this program, it prints out whatever is in here. And along with statements, so I'd say the other main part is you have expressions. And expressions, this is an expression inside a statement, and expressions are things that evaluate to some value. So there's something that you can look at and decide sort of what kind of thing comes out of it. And here, what comes out of this is you add these two, I like to put spaces around my operator. It doesn't print out 1 plus 2, it prints out the result of doing the math of 1 plus 2. So 3. All right, so statements and expressions are, and when you look at code, you should be deciding whether this is something that does something or whether it's something that evaluates the something. Then we can make variables. Variables are named locations to store data. And there are sort of three main parts to creating a variable. One is declaring what type the variable is. In this case, we're saying it's an int, which means it's I want to say like a whole number, but that's even more specialized, but basically it's a number without a fractional part. You give the name of the variable, and there's some rules for how those names can be constructed. We also use camel case for this, which starts off lowercase, and then where there's a word break, you capitalize to fit them all together. Other languages like to do something like this, and it's really just convention. And then we assign, in this case we initialize this variable with a value. And of course this could be an expression, right? So as long as that turns into some kind of value, you can use it to initialize this thing. Later we can assign a value to this variable, and the assignment operator, the way you think of it is you look at the thing on the right and you evaluate this expression, whatever it is. So you sort of ignore what's going on over here at first. You just say, tell me what value this turns into. 3 plus 2 plus 1 is 6, and you take that 6 value and store it in value. And then of course it's always good to, oops, wrong thing there. It's always good to check your answers as you go. And I just did something with keyboard. Okay. So if I run this program, it prints out the result is, and here's what we're doing something else. This is a string type, and we are concatenating this text with this number turned into text. So in other words, this whole thing is smart enough to realize, okay, this thing is a string. To add something to a string, we need to put it into the same type. We need to make it consistent. And so it says, what is this thing worth? 6. And then Java knows how to turn that number 6 into text 6. And it concatenates or combines those two and then prints out this resulting string here. Okay, so a lot of programming is writing code to solve problems. In other words, to encode solutions to problems, right? And when we write code, we want it to be general. And so we're not going to always write code to say, what is 1 plus 2? We want to say, what is code to add two numbers together? And we often abstract those away into something called a method. So main is a method, but it's sort of, we don't know much about it, to be honest. But we can write our own methods. Add 2, I think I've done this before. Number 1, 2. And, oops, I didn't even do that right. So let me just write it and then we'll talk about it, right? And let's make sort of a sum equals number 1 plus number 2, return sum, and I'm going to write some code down here to use it, and then we'll sort of see how it all fits together. And I think this is actually, this little section here is where some people are still confused, but is really the most critical thing to get out of this first part of the semester, I think. So I'm going to add 2 of 1 and 2 and print out the, let's just go steal this line here. And let me just make sure it runs, so in case it doesn't, I can talk about it. Okay, so here I'm defining a new method. I'm basically saying, here's code to perform some solution to a problem. And what we're trying to solve here is adding two numbers together. And again, this is sort of template stuff we haven't really talked about yet. This says what kind of result we're trying to compute. What kind of thing does the answer look like? And in this case, it looks like a number, an int number. So we have to say this method is going to produce an int. We give the name of the method. And again, we use that lower camel case form here. And then inside parentheses, we say what data is needed to perform this computation. And in this case, we need two numbers if we're going to add two numbers together. And these are called the parameters of the method. And we can use these like variables inside the method. So here we use number 1 and number 2, and we add them together. Whatever this expression evaluates to, we store in sum. And then we say, the answer we're providing is this value that's stored in sum. Okay, so where do these numbers come from here, and where does this number here go? That's really the main thing. So down here, this is declaring and defining the method. So it basically sets it up, right? It doesn't actually say what two numbers are being added. Down here, we're going to use the method, and we use it by calling it. So this is a method call, and we give the name of the method, and inside parentheses, we provide the data that goes up to these parameters. So in this case, this one value is used to initialize number 1. So number 1 is going to store the value 1. And this 2 value is going to go up here and be stored in number 2. So when I call add 2 with 1 plus 2, then we're going to add 1 and 2 here, store the 3 in here, and return it. This method call is an expression, or it can be part of an expression, and it evaluates to whatever is returned from here. So this call here would evaluate to 3, and the 3 would get stored in result. Now, there's a lot of questions I see about, like, let's say I sent value here, and let's make another number, int value 2, I'll say. Value 2. There's sort of this question is, are these variables here the same as these variables here? Because obviously there's some sort of connection here, right? This thing and this thing are matched up, this thing and this thing are matched up. But there's this barrier between the two, and the barrier is it is the value stored in this variable. So in this case, value has 6 in it. So it's the 6 that gets sent up here, and that 6 value is used to initialize this parameter. So they're not really connected. And the reason, of course, is that I'm not saying that like, well, let's just call value 1 and value 2, number 1 and number 2, and pretend they're the same, because I want to be able to call this thing in different ways, right? So here I'm going to use value 2 as the first one, and I might use, well, let's use an expression, value plus 1. Again, whatever's stored in value 2, which is a 5, gets sent and assigned to number 1. Whatever is in this expression here, which is 6 plus 1, or 7, gets assigned here. So there's a there's a barrier between these two things, and that's good. We want to keep them separate because this way, this is very general, right? I can send whatever two numbers I want, and it adds them up. And next result, I'll just kind of string it all together. Result 2. If I run this, so value plus value 2, 5 plus 6 is 11, and then 6 plus 6 is 12. Okay, so that seems good. But all I'm trying to say is it's easy to kind of think of like, oh, this is kind of the same as this, and this is kind of the same as this. It is important to be precise about how you think about that. The value that's in here initializes this. The value that's in here initializes this. The return value is then captured and stored in a result. I can have this kind of just like raw call. And in this case, this line here doesn't really do anything, right? It does call the method and computes it. That number comes back, but doesn't go anywhere, so it's not remembered. It's not captured down in this program, so it was sort of a wasted effort, right? If there's a return value here, you need to make sure you do something with it. And so that's what I'm doing here. You can also use this call. Again, this is just something that turns into a value in some kind of other expression, right? So I can combine them together here. I don't have to store it here first and then do something with it. I can say, take whatever answer comes out of here and add 10 to it. And that's perfectly fine. And in fact, we could print out the result directly. You know, I could call add 2 here and just print out whatever came out of it. Okay, so that's really the important thing about methods, right, is that they are there to be generically solving some problem. And we are just creating some meaningful numbers here, parameters, and using them to solve our problem and then returning a value out. But there's, you know, until you start seeing it used like in two different places, it's hard to understand why this number is not the same as this number and so on. All right, let's write another method. Also return an int. And in this case, I'm going to sum up an array. I think we've also done this, but it's, I think, constructive. And in this case, we're taking in a collection of values. An array stores multiple items. Let's go make an array before we sort of define this method. So to declare an array, I use an int array numbers. And technically, what's really going on here is I'm making an array object that has a certain number of spaces. So what does this say? It says make me a variable numbers. It's of type int array. And what gets assigned to it? Well, a new array with 4 spaces. 4 0 initialized spaces. So they're going to be all zeros at this point. Now, a lot of times with arrays, we use a shortcut to both say how big it is and what's in it. So this is a special initialization that says make me an array with 4 ints, and the 4 ints should be 4, 6, 8, and 10. So that's what's in the array. Many of you have run into the issue if you print this out, and I need to just comment this out real quick because that's not yet a fully valid method. If I were to run this, I get this funny looking number, and again, we're saying that is essentially what's called the reference. So this array is stored somewhere on your computer memory in a place specifically called the heap. And that new int operation basically says where this thing is stored, and where it's stored gets assigned to this variable. So any variable that is of object type instead of primitive type does not have the value itself stored in there. It has a reference, a location of where that object is. And again, part of the reason for this is that we don't know how big the array really is, and so we don't know how to store it in like one spot, right? That's not completely accurate, but that's sort of one way to think about it. So again, these variables are called reference types, and the variables hold a reference rather than an object. If I want to print out the actual text representation of this thing, there is this arrays to string that we have used, and I can print out the array that way, and I need to import this package to say where that's located so it can find that method. When I run it now, I print out the reference, and then it prints out this nice text representation, which is why we're using that representation like in the assignment, for example, you know, the square brackets and so on. Okay, let's go up and so we want to add up these numbers. So by taking in the array as a parameter, and in here I'm going to use an accumulation loop. All right, I'm fading fast here, I don't know why. An accumulation loop, you basically have two things, right? You have some place to store this accumulating answer, and then you have a loop that looks at each element of the thing we're trying to work on. So I'm going to have an int sum and initialize it to 0. Then I'm going to write a for loop for int index equals 0, index less than the value's length, how many items are in the array. And again, you can't just say, oh, go 4 times, because there's 4 items in our array. You might want to send one with 10 the next time. So you can't what's called hard code that, right? You need to make it general. And then I increment the index to go to the next one. And in here, all I'm doing is I'm adding to sum. So add to sum whatever value is at the current index. And I need to return the sum at the end. Okay. So this is again your basic pattern accumulation loop, some variable to start to hold the answer, the sum so far, and initialize it to an appropriate initial value, loop over all the elements, do something to each of the elements to build towards an answer, add them up into sum, and then after we've looked at all the elements, the sum is now the full sum, and we can return the sum. So I'm going to call that in place. Oops. What? Oh. I'm going to call that in place. The array sum is concatenated with the result of calling, what do I call this thing? Sum array. Sum array given the argument numbers. So numbers get sent to the method used to initialize this. We go over each of them and add them up. And if I run this, sum is 28. Sounds good to me. Not sure. 10, 10, 8, 28. Okay. Now there's some subtlety here. And the subtlety is when I pass this as an argument to this method call, what really happens here? In the prior examples, this value that's stored in the variable gets sent to the parameter and is used to initialize it. The same thing happens here, but it makes you something else happens because it's an object, right? So what's value is stored in here? It is this reference, this kind of funny thing here. That reference is used to initialize this thing here. What that means is that this parameter and the argument parameter are actually looking, oops, this is a, oh no, here. And the argument parameter, the argument variable and the parameter variable now hold the same reference. They are looking at the same array. A consequence of this is, it's hard to think of a method that would I'm going to do a sum array, and it's going to both produce the full sum, but in the array, I want to keep a running total of how the sum is progressing. In other words, in the first spot, it's equal to the first value. The second spot is equal to the first plus the second. The third spot is equal to the first plus the second plus the third. All right. So I'm going to stick into values at index the current sum, because that is the thing that's storing that running total. Now I'm not returning values out of here. I'm just returning a single number. But let's print out numbers here. So I print out the reference. I print out the text representation of the array. I print out what the sum is. And then I print out this numbers after the fact. So the reference, the array, the sum, and here's this array after coming back from sum array. The thing you should notice, of course, is that it has changed. With primitive values, we can do whatever we want to inside the method to the parameter that captured this value, and it doesn't change value or value2 because, again, only the number associated, stored in here was sent to it. It doesn't know anything about value. Here, the reference of number of the array is sent to sum array, which means, again, the array being worked on in the method is the same one as numbers. And so in here, when I am changing each element of the values array, it is really changing each element of the numbers array at the same time because it is the same array, right? Both variables, the argument here and the parameter, are holding a reference to this same object in the computer memory. And if you go into that object and start changing it, it changes it down here as well. So the tricky thing is, in some ways, that it's the same mechanism used to call a method with both a primitive type, like value, and an object type, like numbers. But the behavior becomes a little different because here we're passing this reference thing. I think it's often good if you want to do something like this instead, kind of like you did in the sound processing methods, is make a new array and put the values you want in that new array and return that new array out of this thing. That way it's clear what's going on here, right? The job of this method is to give you a new array with certain values stuck in it. It's less clear here that there is going to be a change to this values array that propagates outside of the method. And you'd have to have a Java doc description that is a careful accounting of this. So you might say sum the values in the array, also modify the array to contain a running total of the sum. And that's sometimes we can describe as the post condition. In other words, what happens to things after this thing is run. Values is an array of int values, not so exciting, return the sum of the values of the elements in values. Okay, so however, in two methods, one with just sort of plain primitive types, but again, values come in, value comes out. We've written another method where we have an object coming in and a value coming out. But because this is an object here with a shared reference to the argument, we can actually make changes to it in the code. Probably the main other thing to talk about a little bit, again, are these Boolean types, which we use in conditions and so on. I think the tricky thing about them is, let's see, game over. Boy, what did I just do there? Game over equals true. And again, these are primitive values, true or false. They can be used in expressions, and you have to learn to recognize them. But we can basically say something like if game over. What am I doing here? If game over, I will just print out game is over. So what does this do? We assign this variable, initialize this variable game over to true. We test for the truthfulness of this expression. It is true in this case because the true thing is true. And we do the true action if that is true. So we say game is over. If I run this, game is over. And of course, we can have an alternate thing that happens if it's not true. And so we print out here, game is not over. Do I have my closing brace? Yeah. And it says game is over still. Now, I just want to point out, this is what we call it. Is a code block, basically it replaces a single statement. Where one single statement is allowed, you can do a code block instead. And so you can have multiple things in here. And this is not a hard Boolean expression because it's always true, but we could say if game is over, or let's make another variable, int time equals 500, so maybe some sort of counter, your game clock, or time is greater than 200, game is over. So how do we evaluate this? Well, this is an or operator, and it combines a Boolean value on the left and a Boolean value on the right. And if either one or both of them are true, this whole thing evaluates to true. Now, in this case, this is going to be true because this thing evaluates to true. That is actually enough to it's called short circuit this expression. As soon as this is true, we know the whole thing has to be true. So it doesn't even bother evaluating this. If this were false, then I'd say, okay, this is false here. We need to evaluate this. Time is equal to 500. Is 500 greater than 200? That is true. This thing here evaluates to true. And so false or true, since one of those sides or both of them are true, the whole thing is true, and it should print game is over here. So game is over. If the time was just 100, in other words, we hadn't gone very far in the game, then this is false, this side is false, and it should print out game is not over. This creation of sort of complicated Boolean expressions is a major source of errors in code, and you need to be very careful constructing these things. You also need to practice reading them and deciding whether or not they're true or false when you see them in code, or really what the intent is of that expression. In this case, if the game is over for some reason, like you ran out of lives or something like that, or you ran out of time, then the game is going to be over. All right, there's a lot of other little things we've done, certainly looking at different code styles, looking at like packages, for example, learning different patterns of taking strings apart and putting them back together. But I think this is a pretty reasonable, especially the stuff with methods here, is really the big picture stuff that I want you to make sure you understand. And there's some slides, for sure, lectures and slides that have, I think, very detailed pictures describing some of this. So if my little moving around of the cursor wasn't fully satisfactory, I would urge you to go back and review those lecture slides and lecture videos and get this process of how values go from the call to the parameter and the answer comes out. Get that really solid. It's really the most important thing for you to understand right now. All right. Thank you. Make sure to do the practice test PDF I have provided, and look over the topics and look over the homeworks, and you should be in great shape for the test.